Shocking pictures of aircraft accidents, but they all have one thing in common. The people. People who fly aircrafts, design aircrafts, work in maintenance or as air traffic controllers. Human errors account for about 70% of all aviation accidents. This film sheds light on how research on human factors may reduce incident and accident rates by influencing simulator training of real airline pilots. Investigation of human factors started in the 70s and was stimulated by the Tenerife tragedy where two jumbo jets collided, leaving the highest amount of fatalities ever recorded in history of aviation. Since then, much has been learned and flight safety has improved dramatically. In fact, ICAO figures from 2009 show one of the lowest accident rates in the past decade, with 0.57 hull losses per 1 million flights. Still, tragedies do occur, and it's the goal of many in the aviation industry to lower these figures. So how and where do we start our research on human factors? Well, first you have to single out what really happens causing the accidents. And for that you have to go into the cockpit. The shell model is a conceptual framework developed by Edwards 1972 and modified by Hawkins in 1975. It is used to examine the numerous interactions between software, like manuals, checklists, procedures, environmental factors like weather and lighting conditions, hardware, that is essentially the aircraft on file, and liveware, being the flight and cabin crew, ground crew, ATC controllers, mechanics, etc. To illustrate the shell model, let's focus on a daily situation like a taxi on a busy airport. The flight crew has to read checklists, follow procedures, start the engines, communicate with ATC. Ideally, all cockpit activities would be linear, where task B follows task A, predictable, with information available when needed and communications done when possible, and controllable, with tasks being initiated by the responsible crew member. However, real taxi procedures more often look like this. The crew's attention is drawn away from the tasks at hand by multiple distractions, be it by ATC, untimely checklist items, or problems arising anywhere else, leaving you with increasing workload and the need to multitask. However, multitasking is not the primary way the human brain works. Attention can be focused on one item after the other, and true multitasking can only be achieved by insidious training of a specified situation. This is where the cockpit simulator comes into play. Multitasking situations increase our vulnerability to errors. In these situations, performing a task from memory typically weakens, and checklist items can easily be omitted, ATC clearances overheard, etc. As we tend to overestimate our multitasking abilities, simulator training should address the need to realize the limits to perform tasks concurrently and guard against omissions by enforcing crew members to actively monitor other crew members and instruments, deliberately perform checklists, create memory cues, and recognize distractions.